Hello guys, welcome to my channel Civology, the study of civil engineering. Today in this video we are going to discuss about the designing of rectangular column. In my previous video we had discussion about designing of circular column, and in this video we are going to discuss about rectangular column, and we will discuss how can we calculate the safe load for a column. If the dimensions of the column are given and end conditions of the column are given, then how can we calculate the safe load which is bearable by this column? So we will be using this Euler's formula. Okay, and if you haven't watched the previous video, must watch that video. It is also very important for to make it very clear, to make your concept. That video is worth watching. Okay, so in this video we are going to find buckling load and then we will find the safe load. So having said that, let's proceed to our topic. Let us have an example to make it clear, or to make it easier for you guys to understand, that let's suppose a column is 3 meter long, is of rectangular section of size 12 into 20 centimeter. Okay, and it is one end is fixed and other end is pinned. As I discussed earlier, that end conditions matters a lot if you design a column. Why it is important, what are end conditions? I have made a detailed video about this topic, the link of which is given in the description, or you can simply click on the I button. Firstly watch that video to make your concept, okay, to clear your concept. And this condition, in this example, one end is fixed and other end is pinned. Okay, just keep that in your mind. Okay, find the safe compressive load using Euler's formula and allowing a factor of safety of 3. Take E, which is modulus of elasticity, as 210 multiply by 10 key power 6 10 raised to the power 6 kilonewton per meter square. Okay, and what is Euler's formula? Euler's formula is usually used for long columns. What is long column and short column? Again, this is some another topic, and the link of this video is also given in the description. Also watch this video. Difference between long column and short column is also very important before going into the designing of the column. And it is used for buckling load. Okay, and buckling load is determined by using this formula, and this formula states that P is equal to pi square EI divided by LE, and LE is effective length. Okay, what is effective length? It is also discussed in the previous video. uh, as these all things are interconnected. Okay, must watch the related videos. The link is given in the description. P is for buckling load. Okay, and E is for modulus of elasticity of the material. I is least moment of inertia. This factor is very important, that least moment of inertia. In my previous video we used only one value because it was circle, and moment of inertia is same for on all sides and equal on all sides of the circle. And in this it is very important to note that it is least moment of inertia. I will explain it on my next slides. Okay, least moment of inertia of the column of the section, and L is equivalent length or effective length of the column. So as as it is told in the example, that the height of the column is 3 meters and its cross section is given as over here, as you can see, 12 centimeter by 20 centimeters. As I told you before, that end conditions are very important before designing of any column. So here the end conditions, as you can see over here, there are different end conditions. Okay, both ends are pinned, then equal actual length is equal to effective length. Okay, again it is very pertinent to mention over here that if you want to clear your concept about effective length, watch the related videos given in the description. And if both ends are fixed, you can say one end is fixed and other end is free, then equivalent length is equal to 2 times of actual length. And if both ends are fixed, then effective length is equal to LE, that is half times of its actual length. And if one end is pinned and other end is fixed, then effective length is equal to 0.7 times of actual length. So over here in this example, one end is fixed and other is pinned. Which one of that is it is number D. Okay, one end is pinned and other is fixed, so we will be using this value, that is effective length is equal to 0.7 times of its actual length. Okay, so let's proceed to its solution. Let us extract the given data. The size of the column is 12 by 20 centimeter and the length of the column is 3 meters, or you can say 300 centimeters, and the modulus of elasticity is given as 210 multiplied by 10 raised to the power 6 kilonewton per meter square. And buckling load, we will have to find the buckling load and then we will convert it into safe load. Okay, and the formula used as discussed earlier is Euler's formula. P is for buckling load, and all the other things have been discussed. Let us proceed towards the solution. So as you can see over here, this formula I, we will need to find I. What is I? I is the least moment of inertia. So IXX, what is moment of inertia? This is also related video, the link of which is given in the description. To make clear your concept, or to, if you want to understand it in better form, then must watch the related videos. Okay, Ixx is moment of inertia. Ixx is equal to bd cube divided by 12, where b is 12 and d is 20. Okay, and it is equal to 8000 centimeter power 4. The unit of moment of inertia is cm power 4. Okay, and Iyy is db cube divided by 12, and Iyy is equal to 2880 centimeter power 4. As I discussed earlier, that we will be using the least moment of inertia, the one which is smaller. Okay, this value will be used as we are going to design the load for column. Okay, and as end conditions are discussed, one end is pinned and other is fixed. So in that conditions, as I told you, that the effective length will be equal to 0.7 times of its actual length. Okay, so by putting values, the actual length is 300, the effective length will be equal to 210 centimeters, by having in mind this condition. Okay, so by using this formula and by putting values, we, as you we know that 3.1514 square, which is the value of pi, and the value of E is 2 multiplied by 10 raised to the power 6, and this is least moment of inertia 2880 divided by effective length, which is 210, and its square is 210 times 210. Okay, we will get the value 13264.748 kilonewton. So this is actually the buckling load. Okay, and this is actually the buckling load, or you can say the crippling load, or it is also called as ultimate load. Okay, and we also know that the structural members are not designed for ultimate load. We will have to apply factor of safety for its calculation, and safe load is actually buckling load divided by factor of safety, and it is given in the example that factor of safety to be applied is 3, and we will get the safe load, which is 4421.583 kilonewton. So that's how you can calculate the safe load for any given column if given condition is, and conditions are known to us, and the dimensions of the column are given. Then we can calculate the ultimate load and safe load. So guys, that's all for today. If you are new to my channel, you are requested to please subscribe it, and don't forget to press the bell icon to get video updates. That's all for today.